Now let us do the second math. In the second math, it is a synchronous Tdm math. In this synchronous Tdm math, it says that we need to use the synchronous Tdm and combine the 20 digital sources. So this is my number of the channels, and each of it's 100 kilobits. So this is my input rate. Okay, this is my input rate for each of the channels, each of the 20 digital channels. Each output slot carries one bit from each digital sources. So the each output slot, it means that they are talking about the frames, the output frames, and then we have how many slots we have? We will have the slots number of the slots will be 20, because we know in the synchronous TTM, the number of the channels is equal to the number of the slots in each frame, if from using this formula. If you know this formula, number of the input channels is equal to the number of the output slots in each frame. Now they are sending that each output frame in the inner each of the output slots, they are carrying one bits from each of the sources. So there will be one bits, there will be one bits, one bits, one bits, one bits, something like this up to. So there will be 20 bits from 20 digital sources in each of the, and each slot will carry carrying one bit from each of the digital sources. So the frame size, now the following is about the one extra bit, but there's a catch. Now they are saying that, but one extra bit is added to the each frame for the synchronization. We know the synchronous TDM, to sync that signal clock and the receiver clock, we might also use some kind of sync bits, and the sync bits is basically a single bit or with the pattern of 101, 101, 101. In this method, the pattern will be following, and so the each of the bits, each of the frames, each of the complete frame, this is my complete frame, a frame. So this will be my complete frames. So in these frames, there will be 21 slots, because 20 slots are from the digital sources. The 20 slots, these 20 slots will be my digital sources, plus there will be one slot for the synchronization bit or the sync bit. So there will be 21 slots in total. Now they are asking us, the very first question is asking us, what is the size of an output frame in bits? Okay, what is my size of the output frame in bits? Basically, we know there will be 21. So basically, the thing is that there will be 20 bits or 20 slots from the digital sources. So 20 bits, 20 slots, because each of the source carrying one bit, and there will be one extra bit added for the synchronization part. So so there will be 20 plus 1. So the question number 1, the end answer will be 20 plus 1 is equal to 21 bits. So this is our very first question. And the question now says that what is my output frame rate? Okay. So what is my output frame rate? This is a little bit different. So the output frame rate difference, because we know that what is my output frame rate? My output frame rate is going to be the input rate divided by multiplexing unit, or we can also find the output rate is using the formula of 1 divided by T of 0, where the T0 or T0 is the output frame duration or the input frame duration. This is going to be 1 divided by T0. But we don't know yet that what is my output frame duration. So basically, we have to go for the first of the output frame rate, that is the input frame rate divided by multiplexing unit or the interleaved unit. So what is my interleaved unit? My interleaved unit or the multiplexing unit is 1 bit, because they have been carrying, because the multiplexing unit is number of the bits you are taking, you are gathering from the each of the interval rate from the input rate. So here we know that we're carrying 1 bit, we are carrying 1 bit in each of the output frames or output sources. So basically, so there will be the multiplexing unit is going to be 1. So our input rate, using this formula, our output frame rate, I'm making some kind of shorthand notation. because there is not so much space to write, or I don't want to make these things too long or too big. Output frame rate. So basically our output frame rate is going to be 1 divided by, sorry, not the 1, the input rate. So our input rate was 100 kbps. So basically that means, do it a little bit. So 100 kbps, that means 100 kilobits. So 100 kilobits, this is my, now it is going to be my bps. And then we're going to using divided by multiplexing units. So basically those things are the same. So 100,000 bps, basically those are also the 100 kbps. So my output frame rate is again 100 kbps. One thing I have done a mistake here. The frame rates are not the bps, these are the fps. Okay, so this is basically frames per second. The thing is that I intentionally made this mistake because sometimes we forget about it. We forget about it because we write the output frame rate as the bps, meaning output frame rate are not the frames, are not the bps, those are the frames per second. So you have to be very much careful about that. So you have to write this output fps or frames per second, and basically the 100,000 kfps or 100,000 kilo frames, 100,000 kiloframes per second. So 100 kiloframes per second. And then let us go for this C number math. Math C is saying what is the duration of the output frame? Okay, very simple math. The frame rate is the inverse or reciprocal of the frame duration and the vice versa. Okay, so we know that if for any kind of frame rate, it is 1 by duration or the vice versa. So we already know our output frame rate, and using this formula, what is my output frame duration? If the T naught is my output frame duration, if the T naught, if this T naught is going to be my output frame duration, so basically my output frame duration, is 1 over 1 divided by 1000 kiloframes per second. So 10 kfps, which is going to be resulted in 10 micro, so microsecond, or basically kilofps, or we can also say that this is going to be my 10 to the power minus 6. Sorry, not 10. This is going to be my 1 into 10 to the power minus 6 second, basically 10 microseconds. Or is it going to be 10? Yes, it is going to be 10. It is going to be my 10 microseconds. And the third one, sorry, the fourth one. What is my output data rate? Okay. So what is my output data? So now they're not asking you the frame rate. Now they're going to ask you the data rate. And we already know the output bit rate or output data rate. If we had no synchronization bit, we could easily say the output frame rate, sorry, output data rate is equal to the n times the input bit rate or input data rate, because we know that if we have 100 channels over there, each of the channels is sending 100 kiloframes, 100 kilobytes per second. So basically 100 channels in 100 kiloframes, all these things will be the same. Now the thing is that now we have a synchronization bit. So our frames size are not equal to, our frame size are not equal to the number of the digital sources, because now we have added or appended an extra 1 bit for the synchronization part. So using this formula, so basically, so now we cannot use that formula. We have to go for this formula where we have a synchronization bit. And whenever we have a synchronization bit, this is basically the frame rate in the frame size. So our output data rate or output bit rate, those things are the same. So output data rates, so output data rate is going to be frame size, frame rate is the frame size. So the frame size or frame rate, what's my frame rate? This is my frame rate is 100 frames per 100,000. 100,000 frames per second, and that is going to be multiplied with the frame size. From the question number A, we know the size of an output frame is 21 bits. Basically, it is asking us, basically it's the same thing, it's going to be the same thing. If we send 100,000 frames in 1 second and our frame size is 21 bits, then what is my total output? So 21 bits. So this is your frames. So this is going to be your FPS. So this is your FPS, frames per second, and this is a 21 bits. So 21 bits in each of the frames. So you're sending that amount of these frames, 100,000 frames in seconds, and your frame, each of your frame rate contain 221 bits. So your output data rate will be just a simple multiplication result of those. So that will be your 21 into 00, and then it's going to be a 000. So basically 21 into 10 to the power. So this is also the BPS because we have calculating distance and the bits. Now we're going to turn them into the BPS 10 to the power 6. So basically we can also shorten this. So this is your 21 Mbps. So that's your 21 Mbps. This could be 20 Mbps if your if that part was not added. Okay, if the synchronization part was not added, you could just simply, if you could simply make 100 into 20, so 100 kbps into 20, so that will be your 20 mbps or something. This is your 200, so I think I made a mistake. So that is going to be your 2.1 mbps. That's not a 2000 mbps. This is going to be your 2.1 mbps. So in that case, you could have in 2 Mbps. So basically, that is going to be a 2.1.